Alrighty, CNT125, we're looking at Chapter 9 on wide area networking. So we want to talk a little bit about WAN technologies, explain how routers are functioning and how they're doing this interconnection of networks, ways to secure WAN connections, also a little bit about troubleshooting WAN connections too. So hopefully you remember from 120, LANs would be the networks in a building or a site, if you will. And the WAN or WAN technologies are the things that are connecting those sites or those different networks together. And these transmission methods, these WAN technologies, are differ based on what is needed to connect those sites together. In some cases, what's even available in an area too. So WAN is going to traverse distances, and not all businesses need the same kind of WAN connection, whether it be bandwidth or distance or etc. Factors include for these connections, what kind of traffic load, what kind of bandwidth, what kind of budget do we have, what kind of distance, geography, and sometimes even what is available in an area. Not everything is available everywhere, especially as you get more rural. So, LANs connect nodes. WANs are going to use networking devices to connect different networks across a geographic area. LANs and WANs are usually going to differ at layer 1 and 2, but use many of the same protocols from layer 3 and above. So WANs will differ at layer 1 and 2. When we compare WANs to LANs, usually layer 3 and above is going to be similar. So we start talking IP, TCP, all that is going to be similar. LANs are mostly owned by a company, while they lease WANs from carriers, ISPs, etc. This also applies to the hardware used in both LANs and WANs. The hardware at a LAN is usually owned by the company. WANs are usually owned by who you're leasing it from, the service provider, if you will. Here I put kind of a summary of all these in one spot for you so you could see them as similarities and differences. Connecting nodes, connecting networks together, if you will. Different layer 1 and 2 use some protocols, layer 3 and above. Mostly owned equipment in LAN. WAN is mostly owned by your service providers. And here even reminding you of a LAN. And then when we get to a WAN, we're really focusing on connecting the sites together. We're not so much worried about all the users inside, because that's taken care of by the LAN. Some different options for WAN connections are broadband or dedicated internet access. Broadband we're familiar with. A lot of us have a broadband connection for our house. This type of thing can still be used for a WAN connection for sites. The bandwidth is asymmetrical, meaning upload and download speeds are different. Meanwhile, a dedicated internet access, like a lease line type of thing, the bandwidth is symmetrical. You're getting 100 up, 100 down kind of thing. Those are similar, same bandwidths up and down. One way to do a WAN connection is through DSL. Older technology, but still has a use in many places. Digital subscriber line. This for many people was a step up from doing things like dial-up modem, that sort of thing, into digital subscriber line. This operated over the public switch telephone network, and usually through the use of like a DSL modem, I could connect my computer and my network to a phone line and out to the service provider. Public switch telephone network, plain old telephone system. Remember, originally set for analog, today has been migrated over to digital circuitry and so forth. Just reminding us the public switch telephone network. Real quickly, a couple terminologies to run into with public switch telephone network: CO, local loop, and network interface unit. The CO would be the company that is providing you the service of their switching equipment. They'll have a connection that comes out to you to a box on the side of your house or your facility. That's your network interface unit. And then your customer equipment, this would be the owned by you or the business, if you will. This link here from the CO out to you is the local loop. That's your local loop. This was introduced in the 90s, operating over the public switch telephone network. It was competing with cable broadband at the time, just to give you an idea. Can span pretty good distances. It was able to support data and voice over a single channel, over that single phone line. And it was affected by distance. Closer to the CO, you had a higher throughput. Further away, you got a little bit lower throughput as you got further away from the central office. Now, what it was doing was actually combining together voice and data onto one cable. It was multiplexing them together onto one cable. And here's the idea. My voice, my phone, was only using this frequency range, 0 to 4,000 hertz. All of this frequency range up here was not used for anything. So the idea was, why don't we take that data, multiplex it into this upper range, and then we can take voice and data across the same line. So at your provider, they had a, they called it a DSLAM, and this was a multiplexer that was designed to branch out and give connections to multiple customers. And at the customer site, you had a modem that would take and demultiplex those signals. Okay, so you would have then your phone and your computer. And this right here would combine those together to go to the service provider. At my site, you would have, at your site, you would have your DSL modem. This was there to combine your phone and your computer together to go across the phone line. If I broke out the connection a little bit further, you have this splitter here that's helping make all that happen. So coming from the phone provider, your ISP, the line comes in through your modem, and your computer signaling gets multiplexed into this upper frequency band, and that's what this little modem is doing for you. The splitter is, in this case, in the filter, this is your filter, is filtering out this upper frequency band for just the phone. So when I combine all those together, let me go back here real quickly. Here's the line coming from the phone company, if you will. The splitter split it out for the phone, and this is where the filter is also in here too. And then this goes to your modem. So this is taking just the voice frequency range here, filtering out, this is filtering out that upper frequency. This is sending the whole phone line to here. The modem, if you will, is taking your data from your computer and multiplexing into that higher frequency range. That's what it was doing. At the time, actually I jumped ahead. There was a number of different types of DSL. ADSL was the pretty common one for people, but there were different varieties for different bandwidths. ADSL was pretty common. It was asymmetric DSL. You know, you had a lot of download and very little upload. And again, here is your frequency range. Here's your voice, and then your data used all this unused frequency range. Here again is your filter. This, in this case, is a splitter, and with the filter built in. And then here's your structure again, coming from the wall outlet. Here's the splitter for the phone line to go to the phone, as well as to the DSL modem. This right here is filtering out this upper frequency range. So very, very useful technology for many people for stepping from dial-up modem into a higher bandwidth. Still useful in some business cases for a relatively small bandwidth connection to a site. Maybe if you're dealing with just a point of sale device at a branch of a company, this might just be enough data to have that enough bandwidth to handle that data coming from that branch site. The other WAN technology is cable broadband. A lot of us have that and or are used to that or had that at one point in time, so you're familiar with that. I'll put it that way. Your cable broadband was standard by your DOCSIS, Data over Cable Service Interface Specification. There was different DOCSIS standards. And again, asymmetrical speed. Here's this again here, your cable broadband. Now this was based on coax cabling used for TV, and what you were doing is combining the data and the television together on that coax cable. That's what was happening. Same kind of idea as DSL, combining those two signals together. Typically, there was a hybrid fiber coax system, if you will. Traditionally, this is how it was done. You had a fiber ring connecting out to different areas, and then a coax structure going out to a cable modem at a house. Now, by today, a lot of this here is getting replaced by fiber, but it's the same kind of structure. just to give you an idea. A lot of people use cable modem in their house. This was again then demultiplexing the television and the data across that coax cable. Again, cable modem operating layer 1 and 2. Pretty much everything else similar upper layers. Here's sample cable modem that many people had. Coax coming in, twisted pair coming out to your PC. Again, coax coming in, twisted pair coming out to your PC. And if I start looking at adding in things like television or set-top box, you would have a cable splitter here. A line goes to the TV, the other one goes to cable modem. I think I even have it broken out here a little bit for you as well too. A lot of people had something that looked like this. Here's your coax cable coming in. This actually had a couple network ports for a couple devices. This was combining the router, access point, that sort of thing, plus cable modem into one box. Again, splitter, coax going to your set-top box, other one going to your cable modem and your devices plugging into that. And just reminding us again, we had, in many cases, television and data on one coax line, in some places actually starting to add in telephone or voice signaling on this as well. Like DSL, provide that dedicated and always up connection. You didn't have to dial in like before. There were some differences initially in DSL and cable modem. Cable modem initially was kind of a shared structure, but like I said before, let me scroll back here. Here's your hybrid fiber structure. A lot of this has been getting replaced by fiber since this original structure, if you will. So cable and DSL, two different WAN type connections for, I'm going to say lower bandwidth, but maybe that site connection that is needed. We'll come back and continue on about some other Actually, we have a minute here. I'm just going to hit fiber while we're at it too, because again, DSL cable, some people have migrated onto fiber to the curb, fiber to the home. So with ISPs offering, growing trend for ISPs offerings for WAN connections, there is now fiber too, either fiber to the curb, fiber to the home, offering you, instead of coax there, the fiber of the whole way up to the side of the house, giving you more bandwidth and in this case more distance to get connection. This is an older picture from our one of our previous edition of books, but it kind of shows the idea from your central office. You have fiber cable lines coming out to an area, to maybe a splitter unit, and then fiber cable to a building. Some cases copper or coax going to a house. Well, in many areas, even this comes the whole way up to the side of the house, like I think I have another picture down here. Yeah, this is showing kind of the multiplexer piece of this. Here would be a better picture here. The ONT for many people is on the side of their house, or even maybe in, mine's in the basement of my house. Fiber comes from the pole into this ONT that's in the base of my house, and then I split out to coax to the set-top box, and I even have coax going to my modem / router, if you will. But fiber's coming the whole way to the side of the house. For many people, this is now more normal, and for businesses, this is a lot more normal as well. Leased lines. Leased lines is your dedicated line. So this, you're now going to get a dedicated bandwidth, in many cases a little bit higher bandwidth, and I also get symmetrical. So if I'm getting 100 down, I have 100 up that I can be using to move data out of my company, maybe to another site. This is usually also in conjunction with a service level agreement, and that usually indicates the bandwidth and maybe the response time if there is an issue. If there is an outage, the response time of getting that back online. The cost of this is going to vary depending on bandwidth and again on distance for that connection. Here shows, I think this is the picture in the book showing the lease line connections between ISP and different sites. I threw these in here to get you thinking. Comcast Business, here's a whole bunch of different options they have for connecting. Here is a whole bunch of Verizon options, and if I keep digging through theirs, I start seeing more options, and some of these start jumping out as like, oh, those look familiar. Okay, so your service providers have all kinds of different options depending on the bandwidth and distance your connection. In some cases, even your budget. If you only have so much budget, they're like, well, we have A, B, and C here for this. All right, when we come back, then we'll continue on with some different WAN connections.